In this video, we'll be talking about the standard form of a quadratic function. The best form by far for graphing a quadratic function is standard form. So as a definition, the quadratic function f of x equal a times x minus h in parentheses squared plus k with a not equal to 0 is in standard form. The graph of f is a parabola whose axis is the vertical line x equal h and whose vertex is the point h comma k. When a is greater than 0, the parabola opens upward, as we saw in the last video, and when a is less than 0, the parabola opens downward. So let's take a look at what this would be. So first off, for an upward opening parabola, we would have this picture. Here you can see the axis x equal h. Here we have the parabola h comma k. So this is if a is greater than 0. What about if a is less than 0? Well, then we would have this picture, because here we see that the parabola should open downward when a is less than 0. Okay? So, since it's so useful, it would be nice to know how to get a quadratic into standard form. Well, to do this, we need to recall completing the square. Namely, we know we can make x squared plus bx into the perfect square x plus b over 2 squared by adding b over 2 squared into here. So we go ahead and we add that and we get a nice perfect square. So for example, let's try sketching the graph f of x equals 2x squared plus 8x plus 7. And also identify what the vertex and the axis of the parabola are. So here, first, we're going to complete the square to get it into standard form. So to do that, first, we separate off the 7. So write f of x equal to 2x squared plus 8x plus 7. And then we're further going to factor out the 2, our a. So plus 4x and then plus 7. Then what do we have to do? Well, now what we need to do is we need to add b over 2 squared into here. b over 2 squared is, b is 4. So we have 4 over 2 squared, which is equal to 2 squared, which is 4. So we need to add 4 there. But we can't just add 4 willy-nilly. We need to subtract off whatever we added in. Well, here we didn't actually add 4. We added 2 times 4. So we really added 8. So we need to subtract off 8 to keep things even. Okay? But in that case, what we have is, we now know we have the perfect square of what was in the inside here. So b over 2 is 2. So 2 times x plus 2 squared minus 1. This is now super easy to graph. First off, we see that our parabola, we see that the vertex is h, which is negative 2. This is x minus h. This is k. So this has the form a times x minus h squared plus k. So here, h is negative 2, and k is negative 1. So negative 2, negative 1 should be where it is. We also further have that our axis for the parabola should be x equal negative 2. Namely, we can now graph the parabola easily. And then we just have to scale it by 2, right? So if we go over here and it opens upward, so 1, 1, 2, 3, 4, for instance. 1, 2, 3, 4, 5, 6, 7. All right. If you go over here and we have what? So at negative 2, negative 1 is where it is. We see that our axis of symmetry is there. We also see that we know that we double it now, right? Because the a is equal to 2. So instead of 1, we go up to 2. Instead of 2 away being up at 4, we would double it to get up to 8. Okay. So this is the parabola. Something like that. Okay? Now it's time for you to try an example. So go ahead and sketch the graph of f of x equal 3x squared minus 6x plus 4 in a similar way by identifying the vertex and the axis of the parabola. On the count of 3, I'll reveal the solution. 1, 2, 3. And so here you have your solution. Again, note with the green, I went ahead and put that there so you can see where the completing the square happens and how we chose different values. And so yeah, and then you have your solution. So let's do another example just to make sure that we have the hang of it. We're going to identify the vertex here and the x-intercepts as well. Well, so the x-intercepts actually aren't too hard to find. We could easily find them just off the bat by setting the function equal to 0. So setting f of x equal to 0, we have that negative x squared plus 6x minus 8 equals 0. Let's divide everything by a negative, so we'd have x squared minus 6x plus 8 equals 0. Factoring this, two numbers that multiply to 8 but add to negative 6 will be negative 2 and negative 4. So those should be our 2. So we have that x should equal 2 or 4, and those should be our x-intercepts. Now, for the vertex, we can go ahead and complete the square. Completing the square, we have f of x equals, let's factor out the negative x squared minus 6x. But we're going to leave the negative 8 on the outside, so we're good. And here, we need to add in negative 6 divided by 2 squared, which we see is negative 6 divided by 2 is negative 3, squared is 9. So we need to subtract. We're really subtracting a 9 on the inside. And so we really need to add a 9. Okay? So what we have thus is, breaking this down, we see the inside should be x minus 3 quantity squared. Don't forget the negative on the outside. And plus 1 on the outside. So that should be it. In other words, the vertex we can now read off is h comma k. This would be my h, 3, and k would be negative 1. Or no, just 1. Sorry, just 1. Because there's no negative on the outside. In other words, what we now have is that we can go ahead and graph with this knowledge. We see that at 3 and 1, and we also see the vertex is at 3 comma 1. So this is 1, 1, 2, 3. The vertex should be there. We also see that there's zeros at 2 and 4, and that makes total sense because we have just we reflected our parabola, and it opens downward now, which we can see from the negative leading coefficient. But then what we did is we moved it over by 3 and then added 1 to it. So 1, 2, 3, 4, 5. Here, if we go down to there, 3, that would be where that is. Down here to 3. And so we get the nice parabola that looks like this. Okay. And once again, let's have you try an example. So go ahead and sketch the graph of f(x) equals x squared minus 4x plus 3 and identify the vertex and the x-intercepts. On the count of 3, I'll reveal the solution. 1, 2, 3. So here you can see that it really is just all in all, it's really just it's just the graph of x squared shifted to the right by 2 and shifted down by 1. You can also just compute the vertex by completing the square. You can compute the vertex easily from this. You also can find the x-intercepts, which are 3 and 1, by setting the function equal to 0. Setting the y, you can also find the y-intercept by plugging in x equals 0, which gives you 3. All right, let's try a more advanced example now. Let's write the standard form of the quadratic function whose graph is a parabola with vertex 1, 2, and that passes through the point 3, comma, negative 6. So here we know that f of x must have the form a times h minus 1 squared plus 2 because of the vertex. Well, we also know that, thus, we know that it's got to go through this point. Namely, we know that this tells us that f of 3 equals negative 6. Well, let's plug in 3 then and set this side equal to negative 6 and see what we have. A times 3 minus 1 squared plus 2. 3 minus 1 is 2, so 2 squared, so negative 6 equals 4 times a plus 2. Subtract 2 from both sides, you get negative 8 equals 4a. So a, dividing both sides by 4, is negative 2. In other words, we have that the final solution should be just f of x equals negative 2 times x minus 1 squared plus 2. And that would be the standard form. So I'm sure you're itching to try an example for yourself, so go ahead and find the standard form of a quadratic function whose graph is a parabola with vertex negative 4, 1, and that passes through the point negative 6, 15. And on the count of 3, I'll reveal the solution. 1, 2, 3. So here, again, you know what the vertex is, so now the question is just how to solve for a. You can use this point, which you know means that f of negative 6 equals 15. And thus, we can solve out for a equals 7/2. So that would be our solution. For more practice in working with the standard form of a quadratic function, be sure to see pages 120 and 121 of the textbook and work problems numbers 13 through 26, 35 through 50, and 57 through 62. In our next video, we'll be starting to talk about transformations and monomials.